Welcome back yet again, class. So today we are going to be looking at dividing by binomials this time. So in order to know how to multiply or how to divide by a binomial, we're going to go back and we're going to review our long division skills from way back when to see how did we solve these problems. So long division, what I want you to remember, you're going term by term to see how many fours fit into each one. So for example, I see how many times can 4 fit into 7? Well, 4 can fit into 7 one time. So remember, I would put a 1 above there because that's how many times it can fit in there. Then I look to see how close did I get. So I subtract that 4 off and I get 3. So I was 3 away from what I wanted. Pull down your next number. How many times can 4 go into 36? Well, 4 can go into 36 9 times. And that was actually a perfect fit. There was no difference there. So, pull down the next term. Well, how many times can 4 fit into 3? Well, the answer is none. It can't go in there at all. So I'm going to put a 0 in to represent that, then immediately pull down my next term. 35. All right, how many times can 4 go into 35? Well, without going over it, it can go in 8 times. That'll bring you up to 32. And you were 3 away this time. Now, I'm out of things to pull down. So when you hit that point, when you're out of things to pull down, that means that you're done. So before, you would call that a remainder 3, okay? However, starting for this class, what we're going to call that is 1,908. And then what that really means is you have 3 left over whatever you were dividing by. So that means that remainder 3 is really 3/4 that is left over, that can't come out of that division. All right? So that's a review of our long division process. Now, you may be wondering, why are we reviewing this? Well, the reason we're going over it is because this is how we deal with dividing by a binomial. So, let's look to see what this process looks like. So, when I'm dividing by a binomial, that term that I'm dividing by goes on the outside still, and then on the inside is the numerator. So the first part is actually getting the problem set up, okay? Now, from there, we're going to play the same game. I'm going to go term by term. Now, the way that I'm going to show you is I'm always looking to see how can I get this first term to cancel that first term. Okay, I'm looking to be able to get them to cancel. So, what can I multiply d by to cancel 3d squared? Well, d times 3d would give me that 3d squared. All right, so that's the first thing I'm going to identify is what can I multiply that d by to get that 3d squared? Now notice where I placed it. Because I decided it was 3d, notice where I placed that on the top. I placed it over the d's. Now, what I'm going to do, I'm going to take that 3d and I'm going to multiply this whole d plus 3 by it. Okay? So whatever I just found, which was that 3d, I multiply now that entire d plus 3 by it. Now the reason I'm doing that is because I want to see how close am I getting. So after I do that, now just like before when we would subtract off to see how close we got, that's what we're doing now. And the important thing, why did I want to get 3d squared? Well, because each time I do this, I want to eliminate one of those terms. So now what do I have left? Well, I have negative 4d minus a 9d. So that's going to give me negative 13d. And then just like in normal long division, I'm going to pull down the next term. So now I have negative 13d plus 13 left. So I'm going to play that same game. I'm going to take that d and I'm going to see what can I multiply it by to cancel off negative 13d. Well, d times negative 13, so I'm going to put a negative 13 up there, will give me that negative 13d. So I've identified my next term. So now remember, the next step is that negative 13 that I just found. I'm going to multiply the whole d plus 3 by it. And that is going to get me negative 13d minus 39. Now the reason I'm doing that is because I want to see how close can I get. How close did I get? So now I'm going to subtract those two things to see how far off am I. Well, negative 13d minus a negative 13d, that cancels just like we wanted. Okay, remember the whole point of this is we want that first term canceling each time. 13 minus negative 39. Remember, subtracting a negative is really the same thing as adding. So 13 plus 39, you end up getting 52. Now, just like before, when we had something left, but now there's no more numbers to pull down, when we have that case, remember, that 52 becomes our remainder. However, we are much more sophisticated math students than using remainders, all right? So what we're going to do is instead of calling that a remainder of 52, we discussed what that means. What that means is that 52 is still being influenced by that d plus 3. It's remaining over it. So to write this as an actual answer, that is what we're going to do. We're going to take that 52, write it over that d plus 3, and that's going to be our solution. So again, kind of a lot to digest all at once, okay? Kind of a lengthy process. So we're going to do another example together to keep getting a feel for this. Now, for this next example, the key that I want you to notice is look at the numerator, x squared minus 29. Notice there's something missing. Notice there's no x term there. Now, it's very critical that when we write this out, so x minus 5 is what goes on the outside, it's very critical you leave a spot for x. So considering the x is missing, I'm going to say that means there are 0 of them. But in order to make our work look nice, I am going to leave a spot for that x. So now that I have this, I can begin my process. So first thing I'm going to do, I'm going to look and see how can I get x to cancel x squared. Well, x times x will give me the x squared. So that's my first thing, is locating that x. Now I'm going to take that x and I'm going to multiply it by that entire x minus 5. And it's going to give me that. And again, why am I doing that? Well, the reason that I'm doing that is because now I can see how close did I get. Now, again, the goal, that first term should always cancel. That's always the first thing that we want, is to remove one term at a time. So now 0x minus a negative 5x. Well, subtracting a negative 5 is the same thing as adding. So really 0x plus 5x leaves us with a 5x. And now I'm going to pull down that negative 29. And we're going to play the same game again. What can I multiply that x by to get me 5x? Well, I'm going to be multiplying by 5. So now that I have that 5, I'm going to take that 5 and multiply the whole x minus 5 by it. So that's going to leave me with 5x minus 25. Now we're going to subtract. We're going to see how close did we get. Well, 5x minus 5x cancels like we wanted it to. Negative 29 minus negative 25. This, if you need to, pull out your calculator really quickly to make sure you get the right thing. But subtracting a negative is the same thing as adding. So essentially, negative 29 plus 25 will give me a negative 4. And again, if you can't get that negative 4, please either use your calculator or ask me so I can go more in depth on how to get that. Now, notice, we don't have any more terms to pull down. So that means our process is over. So, that minus 4, that is our remainder. Of what that means by remainder is it is still being influenced by what you're dividing by. So our final answer is going to look like that. So thank you so much for joining me. So please make sure you have those written down step by step, and then come back to class with any questions, and we will move on by doing our practice work.